Alright, so today we're going to talk about sex-linked traits. So these are traits that are linked onto our XX chromosomes if we're girls and XY chromosomes if we're boys. Alright, so let's take a look at some chromosomes. This is a karyotype, which is just a picture of chromosomes. So, here we can see, let's see, I'm going to use a pen. Here, we have the 1, the 2, the 3, all the way up to the 23rd chromosome, which is right here. Which would be, in this case, this is a female because it's 2 X's. And then all the other ones, they code for other things, like our hair, our eyes. And this last pair codes for if we are a boy or a girl, and some other things as well. So we have autosomes. Those were the first 22 homologous pairs of chromosomes. Autosomes are the same for both males and females. Next, we have sex chromosomes. These determine the sex of the individual. The sex chromosomes are the 23rd pairs of chromosomes. So, if we're a female, we're going to be X. Alright, if we are a male, we are going to be X, Y. Okay, so let's talk some more about this. As we said, XX is female, and this karyotype shows it well. We have 2 XX. And then if we look at the next one, XY, our XY is male. And look at that Y. That Y is actually pretty tiny. It only has about, this only has about 12 genes on it. Think about that, just 12. 12 genes, man, that's pretty significant. Alright, 12 genes on that little tiny piece of genetic material. So which parent determines the sex of an offspring? So we have the mom and the dad. Who determines the sex? The dad does. So it's the guy who determines the sex of the offspring. Alright? So, why? So all moms have the genotype XX. If you're a girl, you're going to have this XX. When the egg cells are made, they will carry a single X chromosome. So remember, our moms, they pass an X to us. And all our moms, they all have this. So it has to be the dad who has that extra Y. All dads have the genotype XY. So when sperm cells are made, there's a 50% chance that it will have an X and a 50% chance that they will have a Y. Therefore, males and females are born roughly in a 50-50 ratio. That's why we have half. We could either be half the chance be a female, half the chance be a male. So sex-linked traits. So these are kind of special. Those traits that are controlled by genes on the X or Y chromosomes. So there's actually genes, more genes rather than saying you're going to be a male or a female, but there's more genes on these chromosomes, and we call them sex-linked. Note, the Y is much smaller than the X chromosome and only contains a few genes. Most sex-linked traits are on the X chromosome, so that's very true. As I told you, there's only 12 genes on that Y. So, before we do that, let's take a look at this. So when we write sex-linked traits, we kind of do something special. Let's say the trait is hemophilia. Hemophilia is a blood disease where if you get it, so I'll write hemophilia, I think it's 2 L's, I might be wrong. Alright, so hemophilia is a blood disease, and basically, a person who is normal does not have it. When you fall down, you'll get a bruise, and that's just your blood has clotted. When you have hemophilia, when you fall down and you hurt yourself, you can actually bleed to death because you do not have clotted blood. So we would say if you have hemophilia, that's a recessive trait, so we could call that little h, okay? If you have no hemophilia, so I'm going to put no hemo here, no hemo, so this is going to be you don't have anything at all, then you might be big H, big H. Okay, and now let's say you have it. Now let's say there's also something called a carrier. A carrier. Alright. Carrier. Bam. You'd be big H, little h. Okay, now this is what we do something special with sex links. Because they're either on the X or they're on the XY, we link them to the person. So we write them as like you would an exponent right here. So that mom does not have hemophilia. She has no hemophilia. This boy does. We do not put any traits on the Y. And let's do another one. And then this mom might be a carrier. Because to make a carrier, we're going to have a big H and a little h. Okay? So this is how we write sex-linked traits. We write the X or the XY, and then we put the traits as exponents next to them. So let's do an example. In humans, hemophilia is a sex-linked trait. We know that. Having hemophilia is recessive. So that's going to be H with a little h. To being normal, big H, big X, big H. The heterozygous female is called a carrier. Alright, so cross a carrier female with a normal male. So what's the cross going to look like? So our carrier female, she's going to be that X. I wonder if I can get another color. Let's try. That X. I don't think you can change, that's fine. With the big H exponent, and then we're going to get the X with the little h exponent. And now we're going to cross that with a normal male. So that male is going to be normal, so he's going to have a big H, and then we should not put anything on the Y. Okay, so that's what it should look like. So I'm going to flip the slide and we're going to see if we did it right. Alright, Did we do it right? Yes, we did. See, we got that big H, that little h for the carrier, and then the male is normal, so he's just going to have a big H on the X. So now let's make our Punnett square. So remember, for our Punnett squares, we're going to start with this box. So these two are going to go in first. The big AX with the big H, the big X with the big H. Then we're going to go to the second box. Big A, big X, big H. And then we're going to get the big H little, the big X little h, big X, big H and Y, big X, little h and y. Alright, let's look at our genotypic ratio. So, we have one of each of these genotypes. It's a 1 to 1 to 1 to 1 ratio. Now let's look at this. Phenotype. We have two normal females. Technically, they are normal, but one of them is a carrier. This one is our carrier, right? Because they have that little H. Then we have one normal male. Here's our normal male. And then we have one male with hemophilia. Good. Alright, now let's cross a carrier female with a male with hemophilia. Okay, so we're going to do that. We're going to cross a carrier female. So that carrier female is going to be the big X. And then we're going to do the other big X, and we're going to have little h. And then we're going to have our male. And remember, he has it, so he's going to have a little h exponent. Did we do it right? Did we do it right? Let's look. Yes, so we did do it right. We have our big H, little h, the little h for that male. Let's make our Punnett square. I'm going to put them all into the boxes. Alright, take a moment to look. We have our big H, little h, big H, little h, big H, Y. Alright, we have everything here. Get our genotypic ratios. This is again so 1 to 1 to 1 to 1. And our phenotypic ratio. We have one normal female. That's a carrier. But she's a carrier. We get one female who has hemophilia. That is actually very rare. And then we get one normal male. And then we get a male with hemophilia. Okay, so that's that combination. So we're going to go through this a little bit. We're not going to do that problem. Alright, so let's ask this question. Why are sex-linked traits more common in males than in females? So that's a really good question. So just take a moment to think about it for a second. So, males only has to inherit one recessive allele in order to get a sex-linked trait, and a female has to inherit two recessive alleles in order to acquire a sex-linked trait. So that's why they're more common in males than females. It is easier to inherit one recessive allele than two. That's true. If the female only inherits one recessive allele, then they are a carrier. That's important. Females will be considered carriers, but have the normal phenotype. Oops. Okay, and that's it for sex-linked traits. We're going to do some practice and go over some other things. Alright? Goodbye. Hope you enjoyed this.